Hello and welcome to section 3.3. We're going to really get into one of my favorite topics after we learn to factor, and I really think this kind of comes full circle in the purpose of factoring. So as we go through this here, I think it'll really help to kind of clear up the idea of factoring and why we learn this whole idea. But before we go through this, just kind of reviewing all the ideas we have with factoring. So the first thing we always want to check for, no matter what, is greatest common factor. And we know that we talked about that. We harped on that with our numbers project, with that being the top of our numbers project that we always look for. The only want to ask yourself one of two things, okay? If it's a binomial with subtraction and two squares, then we know it's difference of squares. So I'm going to put DOS for difference of squares. That was very specific, remember, with subtraction, and has two squares with that as well. Then if it's a trinomial, what we want to do is we want to use our X method that we talked about as well. Then if it was a polynomial, we want to do grouping. And then we got into those specific ones of a binomial that has subtraction with two cubes was a difference of cubes. And then if it was addition, it was a sum of cubes. Okay, so we have all those methods in order factoring, which we will use all those methods in order to factor today. So what's the whole purpose of factoring? And I think that's super, super important that we talk about that. The whole purpose of factoring is to be able to solve polynomial equations So those equations that have bigger powers than just one. And, you know, up to algebra 1, we talk all the time about solving just basic one power, get powers of things to the powers of 1 in terms of like x plus 2 equals 4 and 3x plus 5 equals 10, solving all that. So now we have this thing called ZPP, or zero product property. I'm going to go ahead and ZPP, or is what our initials is, for zero product property. Very, very important property that we talk about. And this allows us to be able to solve those equations, polynomial equations, with powers more than 1. So what is a zero? Okay, a zero is where it crosses, or your line crosses, the x-axis. So it's the point at which your line intersects or crosses the x-axis. So we're going to be able to solve for those things today. And we're going to solve it by using our ZPP product. So also just kind of note, just depending on if you go to college algebra, sometimes you'll hear these things called zeros. Sometimes you'll hear them called roots or x-intercepts. So they're all mean kind of the same idea, depending on which term your teacher wants to use. We'll talk about them in terms of zeros today, in terms of for your order pair format. Okay, flipping over to the next page. So the number one goal, and we're going to put this off to the side with ZPP rule, is this. You must have your polynomial set equal to 0. So step number 1 is you must have polynomial set equal to 0. That is the first and foremost. You cannot factor something unless it's set equal to 0. Okay, and then so step 2 after you do that is you're going to try to factor whatever you can. Okay, and from there we'll kind of talk about this as we go through this process. So looking at this first one, we have x squared plus 12x x squared plus 7x plus 12 equals 0. So the first thing we always want to double check is to make sure it's equal to 0, which it is. So from there we want to look what we have left. And if I look at what I have left, I have x squared plus 7x plus 12, and that is a trinomial. So we're going to try to factor this. The first thing we would do is we would try to factor GCF out. Doesn't have a GCF. So since this is a trinomial, I'm going to take first times last. So what numbers that multiply to give me 12, but add to give me 7. And those values would obviously be 3 and 4. From there, we'll just continue to set up. So x squared plus 3x plus 4x plus 12 equals 0. So once again, we're solely focusing on this thing that's set equal to 0, which is that value there. So we're going to continue on with grouping. So I'm going to group my first two and group my second two. So this is just kind of building off our factors that we learned last time. So when I group those out, I'm going to pull out an x to leave me x plus 3. The other one, you're going to pull out a 4 to leave you x plus 3. And we see that they match, so we know we're good. So my final factorization is x plus 4 and x plus 3 equals 0. So now we factored. Okay, so what's our next step over here listing it? What you want to do is set both factors equal to 0. So what do I mean by when we set both factors equal to 0? Well, let's just take a look at this as you write that down. Here's factor number 1, and here's factor number 2. And we have this new rule that we just harped on, which is called ZPP, zero product property. So think about those words. 0, it's set equal to 0. Product, which means multiplication, and property allows us to solve things and to give us rules around everything. So take a look at this. So we're going to take each of these and set them equal to 0. So my first one is x plus 4. I'm going to set it equal to 0. And your other one is going to be x plus 3 and set it equal to 0. So from this juncture, we just solve each of those. So my first x value is going to be negative 4. And I'm going to solve this other one by subtracting. It's going to be negative 3. And so now you've solved both of your x's, so your zeros, and we're just going to focus on these. We will not fill this box in today, so don't worry about that. We're just going to call them zeros. So we're going to fill this in. And so when I do that, I want to write it in an ordered pair format and get used to that. So my ordered pairs, and I'll write it below here, are going to be negative 4, comma 0, and negative 3, comma 0. So a couple things that we need to note that usually everyone gets confused on. Why do we have them as zeros for our y? Because remember, you set it equal to 0, and typically this is your y value. So that is why your y's are zeros. Remember, we solved for x, so it gave us our x values. And then the last thing you need to think about is we said zeros are where it crosses the x-axis. We always know when it crosses the x-axis, our y value will be 0. So that's kind of another reason why those. I want you to get in a habit of writing your values or your answers or solutions in ordered pair format so you truly understand the purpose of what we're doing in terms of solving for x. Okay, so now I challenge you to pause the video right now, see if you can follow our steps, and try example 2. Okay, hopefully you've had a chance to take a look at number 2. Once again, is it set equal to 0? Check. So we're solely going to look at what is set equal to 0, which is x squared minus 16. And we're going to try to factor this. GCF first, no GCF. Next is the binomial with subtraction with squares. So I'm going to try difference of squares. So I see x and x, 4 and negative 4, to set up my double binomial of x plus 4, x minus 4 equals 0. So using my ZPP rule, zero product property, remember it's this product times this one, and we're going to take each of those and set them equal to 0. So x plus 4 equals 0, x minus 4 equals 0. Solving each of these, my first x is going to be negative 4. And my next x is going to be positive 4. Coming down here, writing my final solution, we want to put these in ordered pair format, negative 4 comma 0 and 4 comma 0. Okay, so now I kind of want to make the point of something to see if you're starting to see what I see. If you would notice here, we had two solutions. Here's one solution, and here's another solution. There is something that is super nice called the fundamental theorem of algebra. The fundamental theorem of algebra says your highest power, which is 2, tells you how many solutions you'll always have. 1, 2. So it's kind of something super, super important that we need to talk about and that we will continue to harp on the rest of the year. So your highest power tells you how many solutions or how many times your value or your line typically crosses the x-axis. Now, if it has imaginary solutions, that won't be as true. Okay, but for any time it's real solutions, it will be true. All right, let's take a look at this one. So once again, what I do is I notice my highest power is 2. So I know I'm going to have 2 answers on this one. So if I don't have 2 answers on a test, I know I've done something wrong. So taking a look and try to factor this one, I'm going to try first by GCF. So I should notice that they have a GCF of x. I'm going to try to pull out, and that's going to leave me with x minus 1 left. Now looking at the black, I would try to factor this. I would see subtraction, but I don't have squares, and I would see subtraction, I don't have cubes, so I don't have the difference of cubes or difference of squares. But you also notice here, I'm good because all my powers are down to 1. So I can take each product, my GCF, and my x minus 1, and set it equals 0. So in doing such, the first one is super easy, and you'll love this one. X equals 0. It's done. Nothing to solve on that one. Your one in green, x minus 1 equals 0. Takes a little bit of solving to do. And that x is going to be worth 1. And once again, we're going to plug in our zeros. So our first solution is 0, 0 from here, and then 1, 0 from here. And you are done. 2 solutions because your highest power was 2. Okay, taking a look at this one. A little bit different. Has a highest power of 3. I'll zoom in just a little bit so you can see this. So I know I'm going to have 3 answers in the end. It tells me right there my highest power is 3, so I should have 3 solutions. Let's see what happens. So the first thing I look at this, I probably should notice there's a GCF of 3 and x to leave you with x squared minus x minus 12. So once again, I'm not done, and I should have set equal to 0. So I'm going to go ahead and do that first. Now I'm not done because I want to try to factor this down as far as I can and really get that down to a power of 1 if possible. So I see that I have a trinomial, so I'm going to do first times last. Numbers that multiply to give me negative 12, but add to give me negative 1. So I think to myself, what numbers are 1 away from each other? Those are 4 and 3. I'm going to make my first one negative and my second one positive to give me that negative 1 value. So setting this up from here, I want to go 1x squared minus 4x plus 3x minus 12. Group and group. Pull out an x in the first one to leave you x minus 4. Pull out a 3 on the second one to leave you x minus 4. I should notice I'm on the right track because these are the same. So it leaves you with x plus 3 times x minus 4. And then we'll set that equal to 0. Now, what I always forget, and what you will always forget as well, is to bring down my GCF. I have a bad habit of forgetting that, so please do not forget it. All right, so now look at this. We have them all down to a power of 1, which is perfect. So we're going to use our ZPP rule. ZPP rule is 0 product property. So look at all my different products. I have 1 here. I have 2 here. And then I have 3 here, which is perfect because my highest power is 3. So now I can take each of these and set them equal to 0 and solve. So the first one is 3x equals 0. Second one is x plus 3 equals 0. And the third is x minus 4 equals 0. You can probably solve these all in your head, but I'll notice the first one is 0. The second one is negative 3. And the third one is 4. So coming over here and filling in my zeros, first one is going to be 0, 0. Second one is going to be negative 3, 0. And the final one is going to be 4, 0. Give me my 3 solutions that I knew that I should have when I'm done with my solving on my polynomial. All right. So a couple things to kind of note as we get into, we've talked about calculators, and I think it's kind of cool to plug these into calculators to see. If you would plug these into a calculator, you can do a quick check by placing this into your equation, into our graphing calculators. I think actually Desmos has the best version of this, so you can really see and look for where the line crosses the x-axis, which we've already talked about before. That's why it's called zeros, because it crosses the x-axis and your y value will be 0. Okay, so far we've had some pretty nice examples. Number 2 is not so nice. So what is the big difference between number 2 and all the other examples? Hopefully you've noticed that it's not set equal to 0. So the first thing you're going to do is set it equal to 0. So I'm going to go ahead and add 5n squared and combine it with my other n squared over here to leave you with 4n squared plus 12n equals 0. Now that it's set equal to 0, that's our first check. What we want to do is we want to factor. So GCF first. Looks like I have 4 in common and I have n in common, to leave you n plus 3. Now that my powers are both 1, I can go to my ZPP rule, 0 product property, my two products. So I have 4n equals 0, and your other one is n plus 3 equals 0. Solve each of those. Your first one is n equals 0 by dividing. Your other one is subtract the 3 over to n equals negative 3. I should have two answers. It looks like I do have two answers because my power is highest power is 2. So your solutions are 0, 0, and negative 3, 0. And you are complete. So now I'm going to show you kind of a cheat that I really like, and I think it's super important. When can you simply just use square roots? Because we've talked about square roots. We had a whole chapter 2 on radicals, and I think it's super important that we kind of put that final touch on why we learn radicals. So if you have just one x value, or x squared value, I should say, okay, then you can solve like a normal equation, meaning you don't have like an x squared and an x. So like this, if you have like x squared plus 2x plus minus 9 equals 0, and I'm just making up an example, we wouldn't want to do this. And you don't have to write this down. You can just watch for a second, because we have more than one x value. So we have this x squared and we have this x. So you can't solve like a normal equation. But if you would have something such as this, x squared minus 9 equals 0, we can use this little cheat that I'm about to show you, because notice what you have. You only have this x squared value. So when we just have one x squared value, then you can solve like a normal equation. And you'll see what I'm about to get, and it's going to be kind of an aha moment of putting everything together. Let me clear this out for us here. Okay, so taking a look at this example, we want to solve to find the zeros of the function f of x equals x squared plus 9. So we're going to have to use our brain for a second. So I'm going to rewrite this so you can kind of see. We have talked about this all year long, but I want to make sure we reiterate the fact. F of x and what are interchangeable? We talked about that as y. Super important. We did that all first chapter, which you guys love so much. Okay, the next thing is we are using the zero product property. So what has our y always been? It's been 0 because we're finding out where it crosses the x-axis. So we know our y is 0. So I'm going to take my y out, and I'm going to put in 0 for that. That's why I'm allowed to, because I'm finding zeros. So my y value is always zeros in terms of the x-intercepts. So question is can we use our normal roots? Yeah, because look, we only have, let me highlight this, we only have an x squared. So we can solve like a normal equation. So let's go ahead and solve like a normal equation. I'm going to go ahead and subtract over 9 to leave you negative 9 equals x squared. Now, this is kind of nice because this puts all chapter 2 back into effect right here. How do we get rid of a power of 2? We know we take the square root, we take the square root. So now we really have to use our brains and go back to chapter 2 for a second. So the first thing I need to think about is, what is the square root of negative anything? We know it is I. Square roots of 9 equals x so far. Okay, so far so good. That takes the negative out. That takes us back to chapter 2. But then be super, super careful about what I'm about to ask you. What is the square root of 9? And that usually gets everybody, because they say, oh, it's just 3. And we really harped on this. It's not just 3. It is what we have plus or minus 3i. It's 2 answers. Okay, now I want to really kind of put everything together. So why does it have to be 2 answers? Well, the first thing we know is 3 times 3 is 9. But we also know that negative 3 times negative 3 is 9. So that's one reason why it has to be 2 answers. The other reason why it has to be 2 answers, come back to your normal original problem. Here and here. You see you have a highest power of 2. So that is why you have to have 2 answers, because your highest power tells you how many solutions you have. So that's why that plus minus is so important. If I didn't use the plus minus, I wouldn't have 2 answers. So it kind of pieces it all together. So what are your final answers when you're going to write in ordered pair format? So your first ordered pair, let's use the positive 3i, comma 0. And your other one is going to be the negative 3i, comma 0. And that gives you your 2 solutions, which you have to match your power up here of 2. I really like that problem because it pieces everything from chapter number 2 to this whole thing here. All right, continuing on here, taking a look at this one. Looks difficult because you have a power of 5, meaning you're going to have 5 solutions. So let's look to see if we can find our 5 solutions that we should have. So I'm going to take out my f of x, and we know which is y, and I'm going to put 0 in for it. Next thing I'm going to do, I'm going to try to factor it. I'm going to pull a GCF of x out to leave you with x to the 4th minus 81. And I'll bring down my equals 0 part as well. Okay, so why at this juncture can we take each of these and set them equal to 0 and solve? The reason being is because this is not a power of 2 yet, or lower. If it's a power of 2 or lower, we're able to do that. So we got to try to factor this middle term again. And I think I can factor by difference of squares. Let's see what happens. And I'm pretty sure that x squared times x squared will give me x to the 4th. And I know that 9 times negative 9 will give me negative 81. So now let's look at this factor. We would have x squared plus 9 and x squared minus 9. And I bring down my GCF of x and equals 0. Okay, now we're getting places. So now we can do a couple other things. What I would do is I would stop at this point, because if you look, I can set that one equal to 0. So my first answer is going to be simply x equals 0. Your other one, if you notice, this takes us right back to the problem we did before. You have a power of 2 by itself. We can set it equal to 0 and solve like a normal equation. So let's do such. So you have x squared plus 9 equals 0. I'm going to subtract over 9, so x squared equals negative 9. I'm going to square root that, and we just went through this, but I'll go through it again. Anytime we square root a negative number, we know it's I. Anytime we square root any number, we know it's plus minus. So what is the square root of 9 is going to be plus minus 3i. Okay, looking at the next one. The last one, we have x squared minus 9 equals 0. I'm going to add over to give me x squared equals 9. I'm going to take the square root and square root to give me x equals, well, why not an I this time? Because my 9 is positive. Only when it's negative. On even roots, we use i's. So we have plus minus 3. Because we know that 3 times 3 is 9, and negative 3 times negative 3 is 9. So there's 2 answers, there's 2 answers, and there's 1 answer to give me 5 total answers. So your solutions would be 0, 0, positive 3i, 0, negative 3i, 0, 3, 0, and negative 3, 0, to give your 5 total solutions that you had from the beginning. All right, continuing on with different examples. Taking a look at this one, I challenge you to pause this on your own and see if you can factor it and see if you can find all 4 solutions that you should have. Okay, hopefully you've had a chance to do this. Hopefully you noticed from the beginning that it was not set equal to 0, so it's subtract over my 28, and want to put it in the format of standard form. So notice I put it in order first, if you're good with that. Now, why can we factor this by x method? Well, first I should look for GCF. Then I should ask myself, can I factor this by x method? We talked a lot about this, but since this is half of my first number, I'm typically able to solve, or factor I should say, by x method. So I'm going to do first times last. Numbers that multiply to give you negative 28. But add to give you negative 3. So hopefully you got those numbers to be negative 7 and positive 4. So we go back to my problem, which had been x squared minus 7x. Oops, sorry, let's go back to that. Don't make that mistake. X to the 4th, I should say, minus 7x squared plus 4x squared minus 28. All right, let's factor by grouping now to finish off my x method. Hopefully pulled out x squared, and you're left with the value of x squared minus 7. Pull out 4 on this one to leave you a matching one of x squared minus 7, which we love. Since those match up, we know we're golden, so we have x squared plus 4, and your other one is x squared minus 7. Didn't have a GCF, so I'm going to bring down my equal 0 part. Now, if you take a look, you should notice I have this one and this one are both x squareds by themselves. So I can solve like a normal equation like I did in the other two examples. So let's first deal with the one in blue. Take it over here to the side. So in blue, we have x squared plus 4 equals 0. We'll go ahead and subtract my 4 over to give me x squared equals negative 4. Then we're going to square root and square root. But square root of x squared is simply x. Square root of any negative number we know is I. And then the square root of 4, hopefully we are accustomed now to, is 2i to give us our solution. All right, the next one we have in yellow, we have x squared minus 7 equals 0. Add that over there to be x squared equals 7. Square root to leave you x equals, and 7 is not squareable nicely, nor can it be broken down, which we should think about, like our little party system that we have when we break the prime factor. So we just take the square root. Anytime you take the square root of any value, we always know we want a plus minus in front, and we're just going to leave it square root of 7. So that gives us our 1, 2, 3, 4 answers. So we come over here, and we're going to write this in our ordered pair format of 2i comma 0, negative 2i comma 0, square root of 7 comma 0, and the negative square root of 7 comma 0 to give us your 4 different answers that you have, because your highest power is 4. All right, the final example that we have before we move on to something different is we need to look at a difference or sum of cubes. That is the only type of factoring that we have not done so far. So this one is kind of interesting, and I kind of love this part. So obviously I've told you we're going to factor by difference of cubes. So in terms of difference of cubes, we use that whole SOAP method. If you want to use it, you can. So we're going to break each of them down. There was no GCF. So the first thing we do is just break them down, which would have been x, 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 and 2, 2, 2. So just kind of remember with SOAP, if you want to use it, same, opposite, always positive. So let's fill in our thing. Our same is going to be subtraction this time. Opposite would be addition, and always positive is addition. So now we just fill in our gaps. The first one is just x and 2. We look at our ends first because we know each of these ends is just squaring each number to give you x squared and to give you 4. And then the middle term is always just your two values times each other to be simply 2x. So we're good so far, and we want to put equals 0. All right. So from here, we want to set each product equal to 0 and see if we can do anything special. The first one, super simple, hopefully, and you like that to get you one answer. We know we need 3 total answers because my highest power is 3. So let's look at this next one. What would you try to do on this one? And hopefully the first thing that comes to your mind is, yeah, we probably should try to X method it. So let's see what happens because it's a trinomial. So we do first times last. Numbers that multiply to give you 4 but add to give you 2. So if you sit here and think about numbers that multiply to give you 4 but add to give you 2, there are none. And so this is the issue that you come up with. So you cannot factor this guy right here. Since I can't factor that guy, solving by factoring is impossible. We only have one of the answers, and we need 3 total answers. So what are we going to do? Well, that's the beautiful part about math. We always have a way to solve this, and that is going to lead us into what we call the quadratic formula. So anytime you can't factor anything, you're going to use this beautiful formula I'm about to give you on the next page. So let's flip over now. All right, so flipping it over, I went ahead and wrote in my equation. We're going to use the equation that we had on the previous page so that we can solve for other two solutions. So we have x squared plus 2x plus 4 equals 0. We're solely going to focus on just the part that said equal to 0. So we're looking at this part in blue. So we have this nice equation, which I'm sure you've seen before, but we'll talk about it again, called the quadratic formula. The quadratic formula is pretty easy to use if you're patient and use parentheses and slow down. Life's pretty easy with a quadratic formula. So let's talk about this. So the first key down here to look at this is your equation must be what we call in standard form. So what do I mean by standard form? Typically goes ax squared plus bx plus c equals 0. So if I look up here, I have my a value, I have my b value, and I have my c value, and I have it set equal to 0. So let's go ahead and fill in my a value. A values are numbers, b values are numbers, and c values are numbers. So that number in front of x squared is 1, so I'm going to put 1 for my a value. The next is my b value, which is the number in front of x, which is 2. And the c value is the number that is by itself, or our constant, as we call it in math, and that value is 4. So we're going to come and we're going to plug in all those values into this beautiful equation that is written right here. Now, if you're good with it, I'm going to go ahead and plug it in. I have pre-printed here for you. I'm going to plug it in. So it's negative b. So in this case, it's going to be negative 2. And then it's going to be b squared. So I'm going to fill in 2 there. And then minus 4a. And we'll put in 1 there. And c, which is 4 here. All over 2a. Now you're just going to have to memorize this equation. But once you get used to using it 10 million times, it will seem like old hat. So from here, we just simply solve. Now, what I would do is don't look at this as one big piece. We're going to solve what is underneath, or simplify, I should say, underneath my square root or my radical first. Okay, so we would have negative 2, because we're not touching that negative 2 on the outside first, plus or minus 2 squared, which would be 4, minus 4 times 1 times 4. So that would be negative 16 all over 2 times 1, which is 2. Okay, let's simplify that, what is underneath my radical first. So this is negative 2 plus or minus, and that's going to be negative 12 all over 2. All right, now we're getting somewhere. So what I do is I look at this. And so what we need to do is, what do we know the square root of any negative number is? Well, hopefully you answered I. So you got negative 2 plus or minus I square roots of 12 all over 2. So then now I think to myself, okay, square root of 12, is it nice? And it is not nice. So let's come over here to the side and let's break down the square root of 12 if it's breakdownable. So I'm going to break it down like we did in chapter 2, 4 and 3, 2 and 2. Remember, we're looking for groups of 2 because that's my index. So there's a group of 2, and the 3 would stay at home, our little party situation. So that's going to leave you with 2i on the outside, and on the inside is going to stay 3. And the last thing is you're going to bring down your plus minus. You're going to bring down your negative 2, and all over 2. Our 2 value right there. So the last thing we'd want to do is, can we simplify stuff? Okay, 3 is not at the party, but 2, 2, and 2 are all at the party. Well, it goes into 2, 2, and 2, and they have to go into all of them. Hopefully you answered 2 to give you the final answer of negative 1 plus or minus 1i, or I, square roots of 3, and that is it. And that would be your final answer. So the cool thing is there are 2 answers here. There's negative 1 plus I square roots of 3, negative 1 minus I square roots of 3, because we were looking for the 2 other solutions that we needed from the other problem on the previous page. So going back to this idea of keys for the quadratic equation, the first key was it must be in standard form. The second key, the equation must be factored down to a power of 2 to use the quadratic formula. Okay, quadratics are powers of 2, so you have to have a power of 2 in order to do it. So many times people try to use the quadratic formula on things higher than the power of 2, and it will not work. Okay, so let's move on down here. Let's go ahead and, if you want to, try to pause the video and solve this one by quadratic formula on your own. And if not, then I'm going to go over it here in a couple seconds. All right, hopefully you had a chance to at least try it on your own. Hopefully you noticed from the beginning that it was not set equal to 0 and it's not in standard form. So let's go ahead and subtract the 2 over here. So we got 3x squared minus 5x minus 2 equals 0. Identifying my A, B, and C value, A, B, and C. I'll highlight those so you can see it. A is 3, B is -5, and C is -2. Remember, a lot of people think it includes those x's. It does not. It's only the coefficients or constants, okay, that we're going to plug in. So the equation is -b. In this case, it's going to be 5 plus or minus b squared. I'm going to go ahead and put 25 if you're okay with that. Minus 4. A value is 3, and C value is -2, all over twice A, and I'm going to go ahead and put 6 instead of 2 times A. So just kind of quick cheats. Remember, the first thing we want to do is we want to look at this value that is under the radical, and we want to simplify that. So I'm going to start with the multiplication of -4 times 3 times -2. So that would be a positive, what we got here, 12, positive 24. So you have 5 plus or minus 25 plus 24, because this created a positive 24 all over 6. So this is 5 plus or minus the square root of 49 all over 6. So before I break down 49, I always like to ask myself, I can break it down if I want to, or I can ask myself, is the square root of 49 a nice number? And hopefully you answered yes, to give you 5 plus or minus 7 all over 6. I always kind of like to make sure it's not a perfect square before I type it in my calculator or try to break it down. So from here, it's super easy. So look what we have. We have 5 plus 7 equals 12 all over 6, which we know 12 divided by 6 is 2. And your other one is going to be 5. I'm going to go ahead and delete this out so you can see what I'm talking about. I'll rewrite it down here. 5 minus 7 all over 6. So 5 minus 7 is -2 over 6, which is -1/3. So your two answers, if you wrote them in 0 format, which is super nice, 2, 0, and your other one is -1/3, 0. Those are the values where your equation would hit the x-axis or cross the x-axis. So now you have a method in order to solve by factoring, and if you cannot factor it, then you can solve by quadratic formula. Now the beautiful thing, and this is kind of a cheat for you, the quadratic formula will work on any of them. No matter factorable or not factorable, you can always use the quadratic formula. So if you hate factoring, then just really learn the quadratic formula, especially for the ACT. Okay, I know notes are kind of long, so I just want to come down here to an example such as number 3 and number 4. And we're not going to solve these all the way, but I just want to talk about them real quick. So if you notice here, 3 is not in standard form. So we have to put it in standard form. So let's take a look at this for a second. So what I would do is do what's natural, which we want to simplify this by distributing through here to give you x squared minus 5x equals -4. So hopefully now at this juncture, you really start to see, oh, I can get it in standard form by simply adding over 4 to give you standard form of x squared minus 5x plus 4 equals 0. Now it's in standard form. You would identify your A value, your B value, and your C value, and you could plug it in from there. Okay, the other one I want to talk about, and we're not going to solve these, we're just going to set them up so you can see how to solve these, because I think you can probably place them in quadratic formula and to solve these. is this one. And a lot of people want to start by just go ahead and plugging this into the quadratic formula, and you can't because it is not a power of 2. So what would we go about doing? Well, the first thing I would try to do is I would try to factor this down. So if you notice here, I should see that I have a subtraction with squares because I know 3x squared and 3x squared give me 9x to the 4th. And I know that 1 times 1 will give me negative 1. I should say 1 times negative 1 will give me negative 1. Okay? So let's look at this factored form. We'd have 3x squared plus 1 and 3x squared minus 1 equals 0. So now from here, I could take each of these and set them equal to 0. And so 3x squared plus 1 equals 0, and 3x squared minus 1 equals 0. I think we're going to go ahead and finish this one off because I really want to talk about what it looks like when you don't have a b value. Because what you'll notice in this one, you have them down to a power of 2. So now you can use your quadratic formula. See how you have power 2? Because remember, the quadratic formula only works on equations that are powers of 2. So I'm just going to solve one of these so you can see what it looks like. Because right now, notice we have an a value. But do we have a b value? We do not, because remember, our b value is that value that is with x. So our b value is going to be 0 in this case, and our c value will be 1. So if we're filling in our equation, so it's negative b, so it would be 0. I wouldn't put negative 0. Plus or minus b squared, so it would be 0 squared, minus 4. A is worth 3, and c is worth 1, all over 2a, which would be 6. So hopefully you understand why I have those zeros in there, because we do not have a b value, so my coefficient is 0, and it's going to be the same thing for the other one on the other side as well. So let's go ahead and simplify this here. 0 plus or minus the square root of 0 times 0 is 0. And then we have negative 4 times 3 is negative 12 times 1 is still negative 12, all over 6. Continue to simplify this. We would have 0 plus or minus the square root of negative 12 all over 6. We've talked about this, but we'll continue to go over it. The square root of any negative number is going to be I. So we have 0 plus or minus I square roots of 12 all over 6. And the final thing we'd want to do is we want to break down 12 into 4 and 3, 2 and 2. We're looking for groups of 2. So this would be 0 plus or minus 2i square roots of 3 all over 6. Now, you typically wouldn't want to leave it in this format because it's really not simplified, because we know 0 plus anything or 0 minus anything is going to be itself. So in this case, it's going to be plus or minus 2i over 3 divided by 6. Last thing, and I know this is kind of a long problem, is 2 and 6. Can it be reduced? Absolutely can be reduced to 1i over 6, or simply just I over 6. Square roots of 3. Don't forget your plus minus in front. So that gives you 2 answers to solve the idea of 2 answers there. Now for this one, you would do the same exact thing. We're not going to go through it just for time purposes. You could do the same exact thing. Your b value would be 0, and you go from there. All right, the final thing, and I know notes are super long today, but the final thing is we never got a chance to talk about how to handle these type of problems in Chapter 2. So I really want to harp on these because I think these are super important and all over the EOC, and then all over also your test and the ACT. So if you remember back to solving quadratic equations, solving radical equations, let's just say, our number one goal was to isolate this guy right there of a radical. And if you notice in the first one, it is isolated. So from there, we loved it because we knew to get rid of that, we would just take it to a power of 2. And so what you do to one side, you do the other. So far, it seems pretty simple. This 2 and this radical would cancel each other out to leave you just with 2x plus 3 equals, and that we're squaring this whole entire thing, so I'm going to put it in parentheses because that power of 2 goes to that whole entire thing. Now I'm curious to see if you remember anything from chapter 1, and now you see why we learned chapter 1 here in just a minute. A lot of you think we're just going to square this x and square this 9, or square this 3 to give me 9, so it would be x squared plus 9. And that is the biggest no-no ever, and please, please, please do not do that. This truly tells you you have 2 of those, so you have to write it out twice, and this is on your test, so please remember that you have to write it out twice, because we have to do that beautiful thing called foiling. Okay, so when we're going to simplify this, you're going to see why we have to FOIL here, and then it's all going to kind of come to fruition of what we're doing. So let's go ahead and FOIL. First, outers, inners, last, and then we'll bring down my blue part of 2x plus 3. So now what are we going to do from here? Very nice, because we just learned how to do this and how to handle this. We want to set this all equal to 0. So we want to get everything to one side or the other. I'm going to bring everything over here to this side to go ahead and set it equal to 0. So if I notice my x squared doesn't have anything to combine with it, I'm going to combine my like terms of plus 6x plus 9. Now from here, I'm going to subtract over my 2x to leave you with 3 equals x squared plus 4x plus 9. And then finally, I'm going to subtract my 3 over to give you the final result of 0 equals x squared plus 4x plus 6. Okay, so from here, we just did this. You could do it a multitude of ways. You could try to factor it. I'm not sure if it's factorable or not. We'll see here in just a second. Or you could use a quadratic formula, your choice. I love factoring, so I'm going to factor. I think factoring is 10 times easier and quicker. So I'm going to do first times last. 2 numbers that multiply to give you 6, but add to give you 4. And unfortunately, I do not think there are any numbers that multiply to give you 6, but add to give you 4, because you got 1 and 6, and you got 3 and 2. So unfortunately, since it is not factorable, we are going to have to use the beautiful quadratic formula. So looking at the quadratic formula, my a value is 1, my b value is 4, and my c value is 6. So negative b plus or minus b squared minus 4 a c all over twice a, which would be 2 times 1. As always, I want to solve my inside my radical first to give you negative 4 plus or minus the square root. You have negative 4 times 1 would be negative 4 times 6 would be negative 24 all over 2. Simplifying that would be negative 4 plus or minus the square root of negative 8 all over 2. Hopefully this is harped in your brains enough to see that we have a negative value down there. So since that's negative, we know we have an I, so it's going to leave you with negative 4 plus or minus I square roots of 8 all over 2. We want to break down my 8 into 4 and 2 and 2 and 2. We're looking for groups of 2, so 2 is going to come out to leave you with negative 4 plus or minus 2i all over 2 divided by 2. And then the last thing, but not least, we want to look at all our values that are at the party, and are they reducible by anything? And hopefully you said yes, they're all reducible by 2, to leave you negative 2 plus or minus I square root of 2. Now, if you really want to get fancy and write these in this ordered pair format, which I really like, and write it in the 0 format, your first answer would be negative 2 plus I square root of 2, comma 0. And your other one would be negative 2 minus I square root of 2, comma 0, because we love everything in the ordered pair format. All right, last problem of the day, and we are done. Let's take a look at this one. This one's much, much easier, and I think you'll like this 10 times easier. Okay, both of those will be on the test, so we want to make sure we understand these. Okay, so remember your first idea is to isolate this radical, so it is isolated. We want to square both sides, so I'm going to square and square. I'm actually going to clean this up so you can see this a little bit better. Okay, hopefully you see that I squared both sides now. So that's going to leave you with x squared equals 3x plus 70, because we know that this square and the square root cancel each other out. Oh, from here, I should see something. Oh my goodness, it's almost in standard form. We want to bring everything over to the left side. I'm going to bring it over here. You're good with that. So I'm going to subtract both pieces over because they're both positive. So it's going to leave you x squared minus 3x minus 70 equals 0. So once again, I want to try to factor, because I love factoring over the quadratic formula. So I want numbers that multiply to give you negative 70, but add to give you negative 3. And I think I have something. So negative 70, but adds to give you negative 3. I'm pretty sure I could make this negative 10 and 7. And I think it's going to work. So let's go ahead and continue to factor. 1x squared minus 10x plus 7x minus 70 equals 0. Ooh, I like this one. It's always so much nicer when it factors. Grouping. Pull out x equals x minus 10. And pull out 7 to leave you x minus 10 equals 0. Take each piece from here. X plus 7 times x minus 10 equals 0. The zero product property, which we've talked about the whole entire time. First property, second property, or second product. I shouldn't say property, I should product. Set them both equal to 0. So x plus 7 equals 0. And x minus 10 equals 0. Solving both of those, it would be negative 7. And it would be positive 10, which is 2 answers, because I should have 2 answers, because that is what I had up here as a power of 2. Now, we always want to write these in ordered pair format to look really sophisticated and mathematical. So there are your ordered pair formats where it crosses the x-axis. So beautiful examples there about, I know notes were super long, but why we factor. If we can't factor, we use that beautiful thing called the quadratic formula. And then we also kind of piece everything from chapter 2 back together with how to handle these values that have radicals in them with powers of 2, and you can learn to factor or use a quadratic formula. So great examples for today. Hopefully this helps. I will be back next class, so if you need any help, please reach out to me by email or come by during ACT Lab. Your assignment for today is a little bit different. You're going to have, I think, 10 to 12 problems on Delta for homework. We have a new little Delta Plus that I'm excited about showing you guys when I return, but go ahead and do those 12 problems, 10 to 12 problems for homework. Kind of give me an idea. You'll have 3 chances at each of those, so take your time, give it a whirl. It'll tell you instantly whether you're wrong or right, which is where we love Delta so much, so you know, see if you know what you're going, or if you know what you're doing. Please take your time on those and work those for the remainder of the hour. Those are due next time. We will check those in class next time, so please have that done before next class.